Hello everyone and welcome. My name is Liz Temper and I'll be your moderator for today's WJE webinar, using full-scale fire testing to demonstrate building code compliance. During the next hour, WJE fire protection engineer Mike Rzeznik will review a case study in which full-scale laboratory fire testing demonstrated that a previously approved ESFR upright sprinkler was capable of protecting double-row rack Group A plastic storage at a higher ceiling height than the sprinkler was originally listed. The resulting solution was able to effectively protect the warehouse while also saving the owner considerable construction costs, as well as preserving the long-term real estate value. And now I will turn it over to Mike to get us started. Mike?
Thank you, Liz, and thank you everybody for signing into this webinar today. I'd like to start off by pointing out the learning objectives for the presentation today. We're going to be talking a lot about alternative design concepts, creative approaches to solving problems in an existing building, and ESFR sprinklers in particular. Just a brief outline of what we're going to go through today. We're going to start with a little bit of background about this case study project that we're talking about, which was a large distribution warehouse, as you can see by the photograph. Give you a little bit of a building description. We've got a video as well that will help walk us through the building and give you a little bit better perspective than photographs. Talk about some of our initial field observations that we made while on site. And then we'll spend a good amount of time talking about the analysis procedure that we went through on this, and it was certainly an interesting one for us as we went through and tried to solve this problem. We developed our proposed solution, which was obviously a fire test. We'll talk a little bit about that, and then we'll go through the results. Now, as engineers and architects, building professionals, we all consider ourselves creative and like to employ creative solutions whenever we can to solve the problems that we're faced with. And one of the great tools for being creative is making sure that you're asking yourself the right question. And as we go through our lives as professionals and as people, we tend to get lulled into asking ourselves the obvious questions, the questions that appear right in front of our face. Like as we look at this diagram, we might ask ourselves, how many circles do you see? Or how many triangles do you see? But in being creative, a lot of times it's about making sure that you're asking yourself the right question. And I'll get back to that diagram and the analogy that I'm trying to draw with that later on in the presentation, and hope you'll see where the tie-in is with that. So a little bit of background on this project. This was an existing distribution center in Dallas, Texas. The building was on the market to get sold, and as part of that process, you're probably familiar with the due diligence surveys that a lot of prospective buyers will go through, and that's what happened in this project in particular. And in going through the process, a fire protection engineering firm that was involved in doing the survey identified a number of sprinkler-related issues with the building. You can see some of them listed here: random sprinkler actuations over the past several years. They noted improper deflection distance between the sprinkler and the ceiling. But the biggest problem that was observed as part of this due diligence survey that was conducted was obstructions to the ESFR sprinklers. Now, ESFR sprinklers, I'm sure many of you know, are early suppression fast response sprinklers. We'll talk about those a little bit more detail in the next couple of slides. But ESFR sprinklers are very susceptible and very sensitive to obstructions. And in this particular case, so many sprinklers were obstructed that the recommended fix for this was removal and replacement of the existing ESFR system with a new one, which was expensive. The estimated cost was about $1.5 million. It was a lot of money. And the owner felt it was a lot of money, and as a result, they wanted a second opinion to see, first of all, is this a legitimate problem? And secondly, to evaluate whether or not there was a less expensive way to get an effective solution in place. So that's where WJE got involved, and I got involved personally to help try to sort this out. So a little bit about the building. The building had an average height of a little over 34 feet. It was 32 feet at the eaves, which sloped up to the peak, which was at 36 feet 10 inches. The three center bays along the spine of the building all exceeded 35 feet in height, and that 35-foot height becomes critical as we tried to solve the problem later on. You can see from the photograph the size of this warehouse, and you could also see the bottom chord of those trusses, which were the primary obstruction that we were faced with regard to the sprinklers. The building had an area of about 500,000 square feet, which is a pretty big building. Just to put it in perspective, that's approximately 9 football fields. If football doesn't mean anything to you, that's about 255 Starbucks, so maybe that will help some of you. The building was constructed in 1993, right around the time when ESFR sprinklers were starting to get a little bit more popular for use in warehouse situations. The building had an unprotected steel frame, a concrete floor slab, consistent with what the International Building Code would refer to as a Type 2B building. For protection of storage areas, you care a lot about what you're storing, how high you're storing it, and how you're storing it. In this particular case, right now, the building was housing, or is housing, Class 2 commodity bulk building insulation products. You can see them in the photographs here. Maximum height of about 24 feet, solid piled, encapsulated, high piled, encapsulated on wood pallets, in corrugated cartons. So not all that challenging to fire. No idle pallet storage within the warehouse, so that was a good thing. But this warehouse was constructed for use by a variety of tenants. So this particular tenant had about a 5-year lease, I think, at the time of the survey. I think they may have re-upped it, but the point is that the warehouse owner wanted to make sure that the sprinkler protection for this warehouse was capable of serving a wide variety of tenant types with a wide variety of material storage, which is why ESFR sprinklers, early suppression fast response sprinklers, were so important to them for this building. So this is a quick video to give you a little bit of a walkthrough, a better idea of what the building actually feels like to be in. This actual video was taken after construction had implemented our solution. So if you look quick, you can maybe see up there at the top the solution that we implemented with the sprinklers. You also got a little bit of a better view of the truss system that acted as the predominant obstruction to the sprinklers that we saw in place. This is actually was filmed during our final CA visit to the site. But you can see very large building, and replacing the entire sprinkler system in a facility of this size would just be very expensive and disruptive as well. So that's certainly something that the owner wanted to avoid if they could do it safely. So let's talk a little bit about the sprinkler system that was in place. You can see a close-up photograph of the existing pendant ESFR that was in place at the facility. K14 sprinkler ESFR, one of the first ESFRs on the market. The design basis for that system was 12 sprinklers operating at a pressure of 75 psi, which translates to about 121 gallons per minute coming out of the most remote sprinkler. The sprinklers were spaced 10 by 10 and were 165 degree Fahrenheit temperature sprinklers. Due to the size of the warehouse, the building was protected with 16 wet pipe ESFR sprinkler systems throughout, each monitored by a water flow switch. And as I said earlier, one of the benefits of ESFR sprinklers is that if you have those, then rack sprinklers are not required. So if you decide that you need to install racks, if the tenant that's coming in needs racks, you're not worried about having to install racks where you didn't have them, and vice versa. If you've had a client in there that was using rack storage and you're switching tenants out to somebody that was using maybe bulk storage, again, you don't have to pull those in-rack sprinklers out. So what is an ESFR sprinkler? For those of you that aren't familiar with early suppression fast response sprinklers, let me just put it in a little bit of perspective, and I'll start at the bottom of this chart just to make it relatable. If you're familiar with shower heads, hopefully most of you are, shower heads on average will put out about 2 to 2.5 gallons per minute. So every morning you get up, you shower, you're getting hit with about 2 to 2.5 gallons a minute of water. Whereas an ESFR sprinkler, you're dealing with about 60 times the amount of water flowing out of that sprinkler, 121 gallons per minute. You'll also notice that the pressure for ESFR sprinklers are considerably higher, hopefully higher than your shower head, but certainly higher than your standard sprinkler, with minimum operating pressures from an ESFR sprinkler of between 50 and 75 psi. So it kind of makes sense if you think about what an ESFR sprinkler is designed for. ESFR sprinklers are designed for big fires. They're designed for warehouse, distribution center fires. So you've got a big fire, you need big water. So you need a lot of it. That's the gallons per minute. And you need a high pressure too, because you're fighting the buoyancy of that larger fuel load. So that buoyancy effect would push the smaller water droplets up. But in order to get that water down to the seat of the fire, you want to have larger droplet sizes and more momentum, so therefore you need the higher pressure. So finally, we had the opportunity to get down to the site to take a look and see for ourselves what was going on with the sprinkler system and evaluate whether or not the observations that were included in the initial due diligence report were accurate, and if they were, what we might be able to figure out to help resolve the problem. So the first thing that we looked at, the first couple things, were what we kind of considered the easier problems, because they were easier to analyze and evaluate, were the deflector distance between the ceiling and the sprinklers, as well as the actuation of the sprinklers. So, right away we got in a lift and got up there and were able to see, yeah, the deflector distances exceeded what was permitted by both NFPA and FM, so that was going to be a problem. In the spurious actuations, we sort of had a good feel for what the problem was there before we even went down. This building happened to be in Dallas, Texas, so Dallas can get pretty hot in the summer. In fact, it averages about 15 days per year over 100 degrees F. So these sprinklers were installed in a warehouse 35 feet or so above the floor in an unconditioned warehouse in Dallas, Texas. So in the summer, those sprinklers over the years were exposed to very high ambient temperatures, and that's really what became the problem with the spurious actuations. So it's pretty easy to evaluate. But the most prominent problem as part of this was the obstructions. So there were two types of obstructions that we had to be aware of and that were noted in the initial report. The first were fixed obstructions, which primarily were the bottom chord of the roof trusses. NFPA 13, National Fire Protection Association Standard 13, which is the installation of sprinkler systems, requires that ESFR sprinklers be located at or below the obstructions, or at least 1 foot away horizontally. FM global factory mutual standards are similar, and you can see the graphic to the right side. It's a little bit more of a graduated curve on the FM global side, but obviously the closer you get into that sprinkler, the more likely you are to obstruct that ESFR flow pattern. So you got to be aware of what's going on in terms of your obstructions relative to your ESFR sprinkler. In getting out to the field, we did confirm that there were plenty of structural obstructions to the ESFR sprinklers. The truss cords were, first of all, 22 inches deep, so they were already going to be below the sprinkler location. And from our accounting, we noticed at least 1,800 sprinklers that were obstructed by the bottom truss cords. So that was not good news, not unexpected, but not good news. Additional obstructions that were noted and that we confirmed were in place at the warehouse were light fixtures, unit heaters, and conduit that were installed at ceiling level that were obstructing individual ESFR sprinklers. And we observed, estimated about 500 of those. Then we had, as we looked at things a little bit more detail, we had some more bad news for the owner eventually when we observed that the proposed solution, which was to demo and reinstall the ESFR system with a new one, that $1.5 million solution wouldn't work. And the reason for that was the roof trusses were spaced 5 foot 6 inches on center. So with ESFR sprinkler spacing being a maximum of 10 feet on center and a minimum spacing of 8 feet on center, that 5 foot 6 spacing of the roof trusses was really a problem because there was no regular geometric spacing that we could come up with for the ESFR sprinklers that was going to match that 5 foot 6 on center spacing of the trusses. No matter what we did, we were going to ultimately run into a situation where we had sprinklers being obstructed by the roof trusses. So that was more problems that we identified when we were out in the field. So that got us, that had us scratching our head because we were really hoping that we were going to be able to come up with a nice, elegant solution for our client. And at that time in the field, it wasn't looking good. So just to go back to take a look at where we started, the initial report indicated that the building had an ESFR system with a solution that would be about $1.5 million in cost, which was too much for the owner to bear. And as I just said, that ESFR sprinkler solution suggested in the initial report that wouldn't work. So that is no longer an option on the table. So we had to come up with alternate options. The first option that we came up with, we weren't all that pleased with. It was a non-ESFR sprinkler solution. So we would use large orifice sprinklers, storage sprinklers that were capable of protecting class 1 through 4 and group A plastic commodities, but it wasn't it wasn't an ESFR solution. So there was limited flexibility in the types and arrangements of storage that would be permitted with that option. And that's not something that the owner really wanted to implement. Also, the approximate cost of that solution was $1.26 million, as you can see in the chart there. Again, relatively expensive, and it would be a workable solution. It would be something that would be permitted by NFPA, but not something ultimately that would fit our clients' needs. So was there an option 2? That's the question that we were faced with. Could we come up with a solution that was an NFPA 13 compliant ESFR sprinkler system? Because that's what our client was after. So in looking at this, we were aware that there were upright ESFR sprinklers on the market. And we were looking at those as a potential solution. The design basis was similar to the pendant ESFRs that were currently in place. In fact, the 121 gallons per minute was exactly the same as the pendants that were currently in place. There were also 100 square foot spacing, so we would be able to reuse the existing spacing. They also had 212 degree Fahrenheit option, so we could increase the temperature rating of those heads and eliminate the spurious actuations. So that another major pro, and one of the reasons that we were looking at the upright ESFRs, is that it would eliminate the issue of the bottom truss cord obstruction. As long as the truss cord is less than 4 inches, according to NFPA 13, we don't have to worry about the bottom truss cord as an obstruction. And in our case, the bottom of those truss cords were 3.5 inches wide. So if we could find an upright ESFR that was listed, then we were golden. All we would need to do is disconnect the mechanical T, rotate those branch line pipes 180 degrees so that the opening was on top, adjust the riser nipples so that we could get the deflector distance that we needed between the sprinkler and the ceiling, install the 212s, and we'd be all set, right? But there were cons too, and the cons were what were really stumping us. If you remember when I talked about the building height, the center bays were all at heights of greater than 35 feet. And the particular upright ESFR sprinkler that we were looking for was not currently listed or approved for building heights of greater than 35 feet. So we had a potential solution. We were close, but we were 1 foot 10 inches away in terms of the sprinkler's listing from being able to use this sprinkler as a solution. So that was a real head scratcher and a real problem, and it was pretty frustrating as well. So that eliminated the sprinkler as a solution. And as we were faced with that, we stared at that language for a long time, not listed or approved. And finally, it drove us to the point where we were asking, do we have an engineering problem here, or do we have a code problem? If it's not listed or approved, does that matter? As long as it's effective. Maybe we're not asking the right question. So that goes back to my graphic that I showed earlier, and hopefully that analogy that I'm going for will tie in a little bit for you here. So if you look at this graphic and you ask the question, how many triangles do you see? You might get one answer. If you ask the question, how many circles do you see? You'll get an answer too. But then if you ask a different question, it changes the answer completely. If you ask the question, how many triangles and circles are there? You'll see that maybe the answers to the first two questions are wrong. And that's kind of the analogy I'm trying to tie in with this, because as we were looking at this sprinkler as a possible solution, one of the questions that we were asking ourselves is there a sprinkler that's listed for heights, upright ESFR sprinkler that's listed for heights of greater than 35 feet? But that's really not the question that was going to help us solve the problem. The question that was going to help us solve the problem is the sprinkler effective at a height of 36 feet, 10 inches? That's the question that we needed answers to. And once we started asking ourselves the right question, that opened up an avenue for us to investigate, to try to see if we had a solution or not. And that the solution that we were looking at obviously was full-scale fire testing. So the first thing that we had to do is we had to speak with the owner about the concept and see if that was something that they were willing to entertain. And you don't really know, they had a choice of a by-the-book solution that was approved by NFPA 13, and they knew with certainty that they were going to be able to implement, which was the non-ESFR warehouse storage protection approach. And it wasn't necessarily the solution that they were looking for, but it would allow them to put the question and the problem behind them. So we weren't really sure how they were going to react to what amounted to rolling the dice a little bit. We felt pretty good about possibly getting a good solution out of this, but we weren't really sure how they were going to feel about it. But they eventually gave us the go-ahead to investigate it. So we started doing some research, and what we ended up doing is we had two candidate sprinklers. The one that we ended up selecting was the Tyco K17 ESFR upright sprinkler. And Factory Mutual FM was kind enough, and Tyco, the manufacturer, kind enough to give us permission to get access to that initial fire test research. And back when it was originally approved, which was back in the early 90s, FM required 4 separate sprinkler tests for each ESFR sprinkler in order to get the FM approval. And what the concept that we developed was, if we could select the most challenging of those 4 fire tests, test that sprinkler at 36 feet 10 inches for that most challenging of the 4 fires and get a passing result, we believe that that would demonstrate that sprinkler was effective at 36 feet 10 inches. And so that is the concept that we proposed. And we proposed that to the local authority having jurisdiction to see if they had any questions with that. And ultimately, they ended up with a couple tweaks here and there, approving that concept. And you can see this is an overview of the UL full-scale fire test laboratory in Northbrook, Illinois. You can see the large-scale test facility in the upper left-hand corner of that image. Again, this is another image of the original test that was done with 24-foot high storage. And this is a plan view of the actual fire test. This is courtesy UL of the fire test that we conducted. Plan view, you can see the ESFR sprinkler grid on top. And in terms of the test that we used, this actually outlays the most challenging fire, which is the ESFR sprinkler centered with the fire being initiated directly between 2 sprinklers. This slide is a couple elevation views again of the test facility. So the UL test facility, it's worth pointing out, has an adjustable height ceiling. So you can customize the height of the ceiling that you're testing to with a great amount of flexibility. So UL was able to get that 36-foot 10-inch ceiling height that we needed for our test. You can see the nominal 30-foot high storage. And everything else with regard to the FM approval test that was originally done as part of the approval process for FM, UL was able to help us customize that and line that up. There were a few things in that original test that we changed, and you can see those labeled here. The most obvious one is the nominal ceiling height. Obviously, we didn't need this to work at 40 feet. So this sprinkler was listed at 35 feet, and typically ESFR sprinklers are tested at increments of 5 feet. But we didn't need it to work at 40 feet. We needed it to work at 36 feet 10 inches. So obviously that was the first thing that we adjusted. The nominal sprinkler pressure is also something that we adjusted. When the original sprinkler was tested, it was tested at a nominal pressure of 50 psi. However, since that time, NFPA 13 had changed to require a minimum 52 psi at the end head for pressures for sprinklers of this type. So we thought that it would make sense to comply with NFPA 13 requirements in that regard. So we tested it at 52 psi, and we knew that our water supply could provide that, so that wasn't a problem. And then the third thing that we changed, which was not a significant change, but it's worth mentioning, is the branch line pipe diameter. In the original test, the FM test was set up to use 2-inch branch lines. And the UL facility typically uses 2.5-inch branch lines. Now, we could have run it with the 2-inch pipe diameters, but because we're running as an upright test and we had the potential for the shadow effect of the pipe beneath the sprinklers, the 2.5-inch pipe diameter would give us a little bit more of a conservative result. And we also felt pretty good that the test was going to be successful, so we didn't feel that it was going to be that much more of a challenge going with a 2.5-inch pipe. There also was a little bit of potential schedule issues in terms of switching some of that pipe out, so we decided that we would keep the 2.5-inch branch lines in place. Now, when you run a test like this, there are 5 pass-fail criteria that are critical for ESFR sprinklers in order to pass a full-scale fire test, and you can see them laid out here. The top 2 have to do with temperature at the ceiling, which are measured by thermocouples and some target steel up at the top of the test arrangement. The maximum peak ceiling steel temperature that you can see during the test is 1,200 degrees Fahrenheit, with the maximum average ceiling steel temperature of 1,000 degrees F, averaged over 5 thermocouples on the target steel. Then finally, some of the other parameters are aisle jump. So the arrangement is set up with 4-foot aisles. So you've got your fire array, and then you've got target arrays on either side. So if the fire jumps the aisle of either of those at all, that's a fail. Also, fire spread to the end of the test array or any of the other arrays is not permitted, so that would also be a fail. And then finally, probably the issue that we were concerned with most was the maximum number of sprinklers allowed to operate. During the test, if you had more than 8 sprinklers operate during the test duration, which is 30 minutes, start to finish, more than 8 sprinklers operate, that test is a fail. During the original test, and this is actually why this was the most challenging of the 4 tests for this particular sprinkler, 4 sprinklers actually operated. And there's really not that much of a difference between 4 sprinklers and 8 sprinklers operating in a large-scale fire test like this. So we were a little bit, of the 5 factors, that was the one that we were going to be paying attention to the most. So here's an image of the test array before we actually ignited, and you can see the fire array in the center, the target arrays on the left and the right side with the 4-foot aisle in between. If you look at the top of the image, you should be able to see the ESFR upright sprinklers on a 10 by 10 grid. And in the vicinity of each sprinkler, UL also has thermocouples mounted so that they can measure the temperature and kind of gauge what's happening temperature-wise up at the ceiling level for the purposes of analyzing the test after the fact. Here's a couple more images of the test array before the fire. One is obviously close up, and you can kind of get a good idea of what 30-foot high storage looks like when you're standing next to it. Again, you can see the ESFR sprinkler grid at the ceiling on top. And the other image shows the igniters that are used when the fire test is actually kicked off. You can see a couple of the white ceramic bricks in there, and on top of those bricks are 4 igniters, which are essentially gauze and paper towel soaked in kerosene in a plastic bag. And so what you'll see when we run the test video, you'll see that the flames initiate rather quickly. So it doesn't really add any fuel load to the fire. It's just there to make sure that when you do ignite it, that you get sustained burning. And in the event that you were curious as to what the fuel is inside those cardboard cartons, it's a 5x5 array of a Group A plastic commodity. You can see it there. Again, photos courtesy of UL. Now, you have, here's a video clip of what we actually saw, and you want to keep an eye at the top. The sprinklers actuate relatively quickly, I think within the first 40 seconds or so. It was, having not conducted a full-scale fire test before this, it was pretty exciting. I was pretty anxious to actually witness this until I got to the actual lab and I was standing next to the client who had about $1 million riding on this. And then it gets a little tense when you see that fire grow so quickly. But you see those two sprinklers actuate really quickly. And at that point, you know, we're kind of wondering, well, those first two went quick. You know, I hope we don't have more than 6 behind them. But the sprinkler performed very, very well, much better than I expected. And those two sprinklers that operated right at the beginning are actually the only two sprinklers that operated throughout the duration of the test. And you can see that they knocked it down pretty quickly, and we're already starting to get that darker smoke that is indicative of control of the fire. And we'll just let this go just a little bit longer. And you can see that ultimately we're going to get full suppression with just those two sprinklers. And when I've got to show you some after photos, you saw some before photos. I'm going to show you some after photos once we're done with the video here. But the entire array of boxes stays in place throughout the fire. So eventually those sprinklers will extinguish this fire on their own, and those boxes stay in place. So we're very happy with the performance of the sprinkler in this case. This next video is a little bit shorter, and we're taking a look at one of the monitors that UL uses to just track those thermocouples. Each one of those green dots represents a thermocouple associated with the sprinkler at the ceiling level. So this is running right now, and again, you'll see the two sprinklers in the center as their temperatures increase. Now those temperatures are Celsius. As those temperatures increase, they'll turn from green to red, indicating that the sprinkler reached its actuation temperature. And this is just another good view to give you an idea of what goes on at ceiling level during a test like this. You'll see temperatures rise, the two sprinklers operate, and you can see the temperatures of the sprinklers on the perimeter just drop dramatically right after you get sprinkler actuation, which is what you would expect to happen. But I think this is just a good illustration of what's actually happening from a temperature standpoint up at ceiling level. So there's that after photo that I promised you. You can see, you know, with the exception of some of the boxes that were pulled out as part of the overhaul procedure at the test facility, that the commodity actually almost looks as it did before the fire test. It's a little closer up view in the vicinity directly associated with the fire. And it's just one more angle of that same test array. So I ran through it a little bit already verbally, but we'll just go through it again. The test results. Again, only 2 sprinklers actuated when 8 sprinklers were permitted, so that's a good result. Clearly no fire spread to the end of the array, and no fire jump across the aisle. So again, those are all passing criteria. In addition to the thermocouples at the sprinklers, thermocouples were mounted on a piece of target steel up at that movable ceiling within the lab. And during our test, we maintained an average steel temperature of 110 degrees Fahrenheit throughout the test, where 1,000 degrees is permitted. So we weren't even close to reaching that fail point for steel temperature. Same thing for the maximum steel temperature. The hottest that target steel got throughout the duration of that test was 127 degrees Fahrenheit, where we could have gotten up to 1,200 and passed. So very, very successful test for us. A very good result. So ultimately, we were able to share these results with the city of Dallas. Now, when we met with the city of Dallas, it was a crucial aspect of the project. I kind of touched on it earlier, but barely. We obviously wanted to make sure that the local authority having jurisdiction was going to accept the results of this test before we made this investment for the client. So we had that conversation with them. They provided us some good input, and we tweaked what we decided to do a little bit based on their input, but it wasn't all that much in terms of changes. We communicated the results of the test with them, and of course, you know, we were kind of waiting with bated breath for the thumbs up from them, which we eventually did get, so that was great. Ultimately, we were retained to help implement the solution, which incorporated some high velocity, low speed fans, HVLS, that's what that stands for, up at the ceiling level to help provide some conditioning in that warehouse space. So with the ESFR sprinklers in place, based on this approach, the value of the asset was maintained, and we also happened to realize a construction savings for the owner of more than $1 million. To go back to take a look at where we started, again, we had a potential ESFR solution that was proposed that wasn't really an ESFR solution that could be implemented. Our option number one was the non-ESFR storage sprinkler solution at 1.6 million or 1.26 million, and then finally, with implementing this a little bit more creative solution of doing full-scale testing of an existing ESFR upright sprinkler, the net cost was a little bit less than $500,000. So some of the project takeaways for me, for starters, and I think a lot of this we all know, right? Don't assume that previously suggested solutions are going to get you the answer that you need. You always got to vet them out, and I think we all do that as building professionals anyway. But it's something that's important to remember. Also, when you're looking for creative solutions, which we do all the time, one of the first things that you need to do is make sure that you're asking yourself the right question, and that can make all the difference in what you see as a real limitation and a perceived limitation. If you start asking yourself the right questions, a lot of those roadblocks that you see in front of yourself that might be blocking you from getting where you need to go might disappear. Now, finally, before I finish up, something else that's important to note. Shortly after we did this test, there was a final round of testing was done by the Fire Protection Research Foundation as part of an ongoing series of tests that had been going on since about 2014, if I have that right. Garner Polanski, who happens to be a WJE engineer as well, has been running that research project for the Fire Protection Research Foundation. As part of that test, or that testing series, 100 ADD tests, actual delivered density tests, were done, and you can see the images of those on the right, to gauge the performance of pendant ESFR sprinklers subject to obstructions consistent with and then more challenging than what is permitted by NFPA, because there was some research that wanted to look into those obstructions to see if the NFPA obstruction criteria for pendant ESFRs was overly conservative. So as part of that test, 100 ADD tests were performed, and finally 9 full-scale tests that were vetted based on the performance of ESFR pendant sprinklers during the ADD tests. And those tests, that series of tests, actually confirmed that NFPA test criteria for ESFR, or NFPA installation criteria for pendant ESFR sprinklers was a little bit more conservative than it had to be. As a result of some of those tests, there are changes coming proposed in the NFPA 13 edition for 2022. And you can actually access the final report from the Fire Protection Research Foundation this coming June. So as it turns out, now the results of those tests would not have impacted what we were doing here, just because the obstructions that we were dealing with in this particular case were variable. And with that, I think I'm ready for your questions.
All right, thank you, Mike. As a reminder, if you have a question, please type it into the Q&A box and hit submit. And we'll try to get to all your questions by the end of the call, but if we don't have a chance to read your question and have Mike answer it, he will follow up with you afterwards. All right, let's go ahead and take our first question. How long did it take you to schedule the full-scale test once the AHJ agreed to accept this approach for this building?
Okay, so yeah, that's a pretty good question. There was a lot of things, a lot of different variables we had to take into consideration as we were trying to get this scheduled. One of the things that I mentioned at the outset was that the building had a pending sale, so there was some incentive for the owner to accelerate the process as quickly as they could. So that was one of the things that we wanted to do for them. So what we ended up doing is we ran the scheduling process with the testing lab, as well as vetting the procedure with the owner and the local AHJ on parallel tracks. So, and then as is anything else, full-scale testing is kind of not surprisingly a long lead item. So we started the scheduling process with UL before we actually received approval from the AHJ, and we had a date selected and reserved. We could always cancel it in the event that the AHJ decided that they didn't want to, that they weren't going to accept that approach. But I would say it probably took us about 2 months to get on the schedule.
Okay, take our next question. Can you explain which tests are code required?
Could explain which tests are code required. I'm not sure I understand the specifics of that question. There are a number of tests that sprinklers generally have to go through in order to get listed and approved. And then, you know, with listings like UL listings and FM approvals, some of the requirements of FM and UL are slightly different. So some sprinkler manufacturers may prefer to test at one facility or the other, or there may be an incentive for them since they may be working with clients that primarily use FM as their approval agency. They may prefer to get their product tested with FM in lieu of UL for that reason. NFPA generally accepts listings from UL and approvals from FM as equal.
Okay, our next question. Do construction savings include cost of testing?
Yeah, so with regard to that, yeah, the net savings there to the owner that's a net savings to the owner of greater than $1 million. Yep.
Okay, our next question. Reusing the old sprinkler pipe was kind of risky. Did the contractor provide a warranty on that work?
Yeah, that's a really good question. We didn't get into this as part of the presentation, but in the original due diligence report, there were some general questions asked about the quality of the existing sprinkler pipe and whether or not it was in good condition. As a result of those questions, what we did is we had samples. The owner had samples of that pipe tested and evaluated in terms of corrosion and deterioration to see if there was any excess or unexpected deterioration in terms of the wall thickness of that pipe, and it came up that the pipe was in really good condition as a result of those tests. So yeah, that's a very good question. It could be considered risky, and it was something that was brought up, and we did look into it, and there was no problems there at all.
Okay, one comment from an attendee from UL. He says, just for everyone's information, that UL can typically test within 1 to 2 months. Okay, our next question. What is the maximum period of time that ESFR heads can be in service before retesting?
That's I believe that is ESFRs. I believe is 10 years. I think every 10 years with ESFRs, they are subject to either retesting or either retesting a sampling of them or replacing them. I can take a look at that and confirm that answer to you, but I think that's accurate.
Okay, the next question. Occupancy type 1, he assumes is S1 and not an H occupancy. Is that correct?
Occupancy type 1. This building was not an H occupancy, if that's the question. This was a traditional storage of class 1 through 4 in group A plastics. So this was not an H occupancy.
Okay, next question. It's not clear what was wrong with the traditional non-ESFR solution. Can you clarify that?
I'm sorry, can you repeat the question?
The question is just, he was not clear what was wrong with the traditional non-ESFR solution. Can you elaborate on what was wrong?
Oh, okay. Sure. The ESFR sprinklers provide owners with a much greater flexibility in the type and arrangement of storage that the warehouse can accommodate. So, you know, you're if you were to go with a non-ESFR solution, you are going to have a limit in the types of storage materials. So you would not be able to have expanded plastics, for example, in the arrangement of the storage. So you would not be able to have double row racks. So you're essentially limiting the types of tenants that the owner would be willing or would be capable of accepting into that facility.
Okay, our next question. I understood that the upright ESFR allowed for obstructions as opposed to the other head type. Did I understand that correctly?
Yes, the upright ESFRs allowed for obstructions depending on the obstruction size. So if for NFPA 13 for NFPA 13 to approve that the bottom, and again, the bottom of the ceiling trusses were the primary ceiling level obstruction that we were dealing with. And as long as those were a dimension that was less than 4 inches in width, which was the case for this particular building, then we could ignore those as obstructions because they didn't affect the sprinkler spray pattern of the upright ESFRs.
Okay, our next question. Did you end up using 212° Fahrenheit sprinklers in the warehouse? And if yes, why didn't you use 212° Fahrenheit sprinklers in the fire test?
Okay. Yes, yeah, so that's a very good question. That's a very good question. In fact, I had that question during the process in which we set up the test itself. We did end up using 212° sprinklers in the warehouse as part of the solution for the reason that we stated earlier. It gets kind of hot in Dallas in the summer. But in terms of why we didn't use them for the fire test, and I had the same question. In the listing process for ESFR sprinklers, the tests are always done with the standard temperature sprinklers, and the pass or fail of those tests are applied to the higher degree temperatures as well. So effectively, if you pass the test with the 165s, you're passing it with the higher temperature sprinklers as well.
All right, we've got time for one more question. Did the City of Dallas attend the fire test?
We invited the City of Dallas to attend, but unfortunately they were unable to. They just didn't have it in their budget to get up to the Chicago area to do that. It would have been great if they were there. We actually kind of wanted them there to see it in person, but unfortunately they couldn't join us.
Okay, thank you, Mike. And thank you everyone for joining us today. We hope it's been educational. As a reminder, you'll receive an email with a link to an on-demand version of this webinar that you can use to rewatch the presentation at your convenience, as well as access related resources, including a PDF copy of the presentation. And that email will also include a link to download your certificate of participation. If you have any questions, please don't hesitate to reach out to Mike. His contact information is there on the screen. If we didn't get to your question during today's call, he will follow up with you afterwards. And if you have any questions about the webinar today, you can reach out to me, Liz Pimper, at lpimper@wj.com. So again, thank you, Mike, again for the presentation. Thank you all for your time, and we hope you have a great rest of the day.